Now we're going to look at multiple regression. Up till now, we've been doing simple linear regression using just two variables. One independent variable, one x variable that we use to predict the y variable. And what we're going to do now is we're going to use several independent variables, several x's, several predictors. For example, with the engineers, we still want to predict how well they're going to do performance-wise, but this time we're not going to just measure ability, which we'll call x1, we're also going to measure the personality trait of conscientiousness, which tends to be a good predictor of job performance. We're going to call that x2. And then what we're going to do is we're going to put the two in an equation, y equals b1 times x1 plus b2 times x2 plus c. So basically, we're going to be able to predict performance from both ability and from conscientiousness. And so we need to calculate these different b's, and then we also need to calculate the coefficient. And that will give us a better formula, hopefully, for predicting performance. And now we're going to use r squared, written as capital R squared when we have more than one predictor variable, to measure how much of the variable is accounted for by these new independent variables, the two x variables. And this is going to be a measure of how good our model is. So for example, if r squared with two variables is larger than r squared calculated from one variable, then the two variable is modeled. If it's just a little bit bigger, kind of what we could expect by chance, we're going to say, no, this new model's not good. If it's smaller, then certainly not good. But if the r squared is bigger than what we could expect for by chance, then this new model with the two predictors is going to be the superior way to calculate and to estimate what we want. So let's look again at this equation that we're trying to get. This is the model when we have two predictors. We're going to say y, that's the predicted value that we're looking for of whatever this variable y is. That would be job performance. B1 is going to be the coefficient of the first predictor value, ability, and so that can be either positive or negative. If it's positive, that means that performance is going to go up as ability goes up. If it's negative, it means that performance will go up when ability goes down. That doesn't make too much sense. I hope the data shows that it's positive. So this x1, this variable, is the first predictor variable that we're looking at. B2 is the coefficient that goes with the second predictor variable. And again, what we're especially interested in is if it's positive or negative. And so x2 is the second predictor variable. That's an individual scores on conscientiousness. And then c is a constant that we're adding to the equation. So we need to calculate from the data b1, b2, and c. And we'll get this equation. And then we also want to calculate r squared to see how much of the variability is accounted for in the data using this equation.